Previously, in the first video, I'll be running the Python main py bar. We got some output over here. I will essentially be playing lots of games, and 10 gigs of data should be enough.
A few moments later.
Hey everyone, welcome back to my channel where I talk about all things tech and finance. And in this video, I'm going to be doing somewhat of a continuation of what I did on my previous video. If you haven't seen that, please make sure to check that out. Link is in the description. So I pretty much just played this game until I had pretty much around 10 gigabytes of data to work with. And I've slowly tailored my script so that I'm actually taking out the unnecessary data so that there's some additional data cleaning process being done in the back end. And for some reason, I'm like really bad at this Dinosaur game. I keep on failing in and out, so my data is not populating as fast as I would like it to. So in order to help alleviate my pain, make sure you hit that like button, hit that subscribe button when you're at it with those notifications on. And so there were a few things that I changed behind the scenes, and one of those aspects was that I'm not recording the space bar anymore. I'm only going to be incorporating the up arrow or down arrow just to make my data more succinct and, avoid any headaches when it comes to actually cleaning the data. So that's happening. Yeah, so I just took out the if statement there, so you will see that difference between this video and my previous video. And one last thing, there's this one portion right here. So over here, I'm just deleting the most recent 10 observations from both my image data and my target data, partly because I don't want to include any data that actually represents a failure because I'm not actually checking that. So just remove the last 10 observations, just fixed it out. And one last thing over here, I played enough games in order to generate close to a little bit more than 10 gigabytes worth of data, and my associated target values for my command keys in this case is 35 kilobytes. So not that bad at all, but as we saw in the previous section of this video was that this was not enough, partly because my data was either one, it did not have good quality, or two, it was not enough. But as we will see shortly, it was probably most likely due to quality. Okay, so assuming that you played enough games in order to generate a vast number of gigabytes that currently exist within your computer, go ahead and go to this particular notebook, and these are the packages that I am using right here. But go ahead and run this particular cell where it's essentially just loading in your data inside of the Jupyter notebook. And note that once you've actually pulled my repository down to your local machine, these pathways should be good to go, and they should be automatically be able to run on your machine, and there should not be any errors. So in this case, I have 81 observations that are associated with my 10 gigabyte file. And this is just the frequency. And as we can see, it's sort of imbalanced. So the 38 values, that represents the value for a up arrow key, and the 40 value is the down arrow key. So let's go ahead and take a look at what one of these actual photos looks like. And as you can see here, it's pretty much just like a screenshot of the screenshot. So I'm only capturing a very small portion of the actual screenshot in order to get the only the necessary details from here. And as you can see, this is pretty consistent with all of my images. It's only capturing that specific area, and it's capturing the actions of this particular dinosaur and the incoming objects. The next step over here is that this is what the grayscale portion looks like. Notice that the game is only gray and white, so it doesn't really do a whole lot. One of the many things that grayscale is doing for us is that it's removing the third dimension, like the color aspect of the specific color. So when we are training a model, it will reduce the complexity and the runtime additive to it. Furthermore, there's actually another reason why we want to run the grayscale, and that is a prerequisite for the edge detection function that we'll be using, and that's called Canny. If you don't want to really get to know the inner workings on how Canny Edge Detection really works, go ahead and skip to whatever timestamp I just put on this screen. It's a multi-stage edge detector. It's very popular in industry. It's also quite effective to just get the most important observations inside of a given screenshot. So the very first step that you would want to do is to do a noise reduction technique. And you would typically do this with a Gaussian filter. And this is pretty much what that blur idea is. So it's getting like an n by n square and this going row and extracting the most intense pixels, and then it will just retain those pixels. So that's where the blurred images looks like. So it's only capturing the most important details. At least that's what it should be doing here. So you can go ahead and just apply the Gaussian blur to all of your images within your particular array, and you should be good to go. So this is just my 7th one. So yeah, it's just clarifying that all my images are in fact blurred. Well, the next step is to identify the intensity gradient of this image. So pretty much like looking at the differences of the directional change within the x-axis and then the y-axis. You can think of it like that. This is how you would do it. You're just finding the gradient. You would use Sobel on that, but you just run that in, and this is what it looks like for the particular image. To look like on just the gradient of that x for this specific image. It's a jumping dinosaur, and we can see the cacti and the clouds in the background. And we can take a look at y over here. So this is the change in y. So as you notice, like there is a very small difference. As you can notice, like the change in y versus the change in x. Let's run this again. So as you can see, it's like the x is like going up in a way, whereas the y is going left to right in a way. So you can also combine these two gradients together to get that type of image. So as you can see, it's only like trying to identify the edges of a specific object, and that's what we have over here. So yeah, this is my attempt at doing a very hacky version of the Sobel technique, which is essentially just trying to find the image gradients of your particular image over here. So the backend on how it's actually done is a lot more advanced than what I'm doing over here, but this is like gives you an idea on how that's actually done. All this other stuff is pretty much came from the person who actually did it, the Canny Edge Detector. So go ahead and see how that's done in the backend if you want to really check that out. After you find the gradients of your images, the next step is to do a non-maximum suppression. And idea here is that it's trying to find the edges, right? But it's trying to take out the irrelevant edges. But also it's trying to minimize the thick edges, because the thicker edges, I guess in this particular case, the thicker edges might look like a double edge, and we don't want that. We want to see that as just only one edge and not two. So that's also where the idea of the double thresholding comes into play, where we provide some threshold, and if the particular pixel value is greater than its threshold, then it will be in this higher pixelated value, so that we will maintain, and vice versa if the pixel value is actually less than that particular threshold. So typically the thresholds are separated by a proportion of a quarter or a half, but it really depends. You can definitely hypertune that to see which is probably best for your particular use case. And then the last step is to do something called hysteresis. I don't even know if I said that right. I probably did not. But yeah, it just determines the double thresholding and which pixels should be maintained based on the idea of the double thresholding here. There's additional material here if you want to check that out, and just further understanding and reading. So you can check out those links as well. Alright, so all of a sudden done, you can go ahead and just run the Canny function, and this is what it looks like. It pretty much just does everything that I've just said, but in a very more efficient manner and effective manner. Go ahead and run the Canny images or the Canny functions on all of my images. I just pretty much just use this function, just append it on an array, and I'm just returning that. And then go ahead and just save that to your clean data set over here. And it will output it in your current directory, and you should be good to go for the next step. So this is actually me saving my data over here. This is actually close to 3.67 gigs. So just notice that this 10 gigabyte file went all the way down to a 3.67 gigabyte file. So lots of data was removed in that sense. So this is what my good friend Zorian has actually created, and I just inserted the data to tune a model. So you can go ahead and read what's on there on the GitHub repository, but essentially what we're trying to do is to create the most simple model. And the idea that came here was a logistic regression, since we had two outputs, jumping or ducking. So just load in your various packages related to the logistic regression idea. Load in your data. In this case, we changed the address so that it's pointing to the cleaned data numpy file, and of course we are using the same keys that are associated with this setup. So go ahead and load that in, and this is the associated data we have with our test sets or training and testing sets. And go ahead and let me just actually run this. So let's run that, run this, and let's go ahead and run that. So this is the image that popped up right here. So this looks familiar. This is the Canny image. So that looks all good and swell. We can look at this on the next image as well. So yeah, it looks good. So it's already converted and it's clean for us. Go ahead and actually flatten it first, and then go ahead and now split the data so that it's in a nice train and test format. Go ahead and print that setup on what that looks like. And we know that the number of rows are good to go. So I already ran this particular model. It only took about maybe like 3 minutes or so. So not a whole lot of waiting was involved. And this was the outcome of that particular model. So the accuracy was astonishingly very, very good. And everything, like the logistic regression just like really went up and excelled at identifying or just classifying these images. And we know that our model didn't do particularly hot when we were actually testing that out, and we will see that real soon. And there are a few workarounds that I might have to come up with, and then that's just like the data quality aspect of whenever I'm pressing down the key, I only want to capture a very specific moment because of the keyboard residue when my finger is going up or down on the keyboards, and it's just capturing all this unnecessary fluff, which may lead to essentially like an overfit we have over here. Okay, so this is my actual setup on just testing out my particular model, and you can go ahead and just replace the address with whatever model that you might have trained on your end to see how well you have particularly done. But this is essentially what I got going on. It's pretty much like a very close clone to my main.py file when I'm actually capturing my data, but there's of course some slight differences here. So we have our main function, and then we're just going to be executing that. Everything is under real-time test. It's pretty much in the root directory on that particular repository that I have set up. So right here, just capturing the window, just locating it out, press the space bar and only the space bar to begin the program. And then this is where the magic is happening. So we're capturing the screenshot. It's getting the ideal pixelated rectangle that we had, only capturing the necessary information, pretty much the same exact input that has been used to train the model. We want to grayscale that, and then we want to utilize the Canny function so that we're transforming that particular image so that we are only capturing the edges, or the more important edges of that particular model. And then we want to predict that screenshots using the logistic regression model that we have loaded up here. And then using that result, it should either come out to be a 38 or a 40. So it's either going to be jumping up or it's going to be ducking. And then if we want to quit, then we just press the letter Q, and then it'll just exit out of the program, and then you should be good to go. And the actual actions that are being sent to the computer without me even touching my keyboards is utilizing the keyboard.send option, and I can specify what type of keys are pressed without me even pressing anything. So extremely useful, although I think it's only available for Linux and Windows users. So Mac users, you might have to use a different library besides the keyboard library because it's only built for a different operating system. Okay, just to replicate what we have earlier in the video, we would want to just first off check out what directory we are in. We are inside the Dinosaur game directory, and we want to run the real-time test Python file. So all we do, Python real-time test, and make sure that you maximize your TRX game, just 2 clicks, because it will look at the pixels differently if it's not in the same exact particular feature space. So let's go ahead and run this, and make sure that when you begin, press the space bar when your mouse is on that particular screen. So go ahead and press the space button, and now I'm not pressing anything right now, and by default it's trying to predict on what it's doing. And as you can see, the model is not doing so hot. Sure, it can do some of these. Oh wow, it's really okay. So it only went to 78, but that's probably the highest that I've ever seen it go to. So there are two aspects that could definitely be improved upon, and I'll do this for my next video. It's going to be the data quality aspect of where I'm only capturing the most relevant key related to your particular screenshot key, so that we don't have any fluff, and we can just remove that excess fluff, and we only have that specific snapshot of when I immediately press that key. I will have that particular snapshot of when it should be jumping or dumping related to Dinosaur. Second part is that if there is no improvements upon the model, then I'll go ahead and maybe just use our more robust model and see what happens. Maybe use some transfer learning such as ResNet. So if you made it this far in the video, make sure you leave a like, hit that subscribe button with those notifications on, and I hope to see you in my next video with a new and brand new model.